Hi, my name is Oktay. Welcome to today's video about images from the Hubble Space Telescope. The telescope was named after Edwin Hubble. That's a very good choice. Edwin Hubble was an American astronomer, and he improved our understanding of the universe. His measurements showed that the Milky Way is just one of many galaxies, and his measurements of the redshifts showed that the universe is expanding. The telescope was launched in April 24th in 1990. This is a nice picture of the planet Neptune from Voyager 2 spacecraft. Neptune is located at a distance of 30 astronomical units. 1 astronomical unit is a distance of Earth to Sun, about 150 million kilometers. Neptune has 17 times the mass of Earth. This discovery was a very interesting story because it was predicted by Urbain Le Verrier from the motion of Uranus. And later it was discovered by Johann Gottfried Galle in 1846. This is a series of Hubble images during its 16-hour rotation. And you can see clouds of methane ice crystals. And the rotation axis of Neptune is tilted by 28 degrees. Orbital period of Neptune is 164 years. This means each of Neptune's seasons has a length of 41 years. And this is a nice picture of the great dark spot of Neptune. It is about the Earth size. And this is a storm system which is over time shifted from the north to the south. That's one big difference of this Neptune's great dark spot compared to the big red spot of Jupiter. Neptune has a ring system like all 4 giant planets. Neptune's ring system was discovered in 1968. The ring system has arcs that come from the gravitation of the tiny moon Galatea. This is a picture of a microquasar, GRO J165540. This is a stellar mass black hole. Stellar mass black holes have typically a mass of 3.5 to 15 solar masses. This is an artist's illustration. This microquasar is at a distance of 5,500 to 11,000 light years. It is a pair of a massive F-star bigger than the Sun and a stellar black hole. And the orbital period is just 2.6 days. And in this picture you can see the F-star is losing material to the black hole. This material is spiraling in this disk. And some of it eventually falls into the black hole, and the rest of the material is ejected by these big jets. This is a picture of IRAS 22036 plus 5306 at a distance of 6,500 light years. This is a cloud from an aged star. The star is ejecting material at a speed of 800,000 kilometers per hour. We are witnessing a formation of a white dwarf and a planetary nebula around the white dwarf. This is a picture of the Artemis cluster, 25,000 light years distance. This is the densest known star cluster in the Milky Way. It's just 100 light years from the center of the Milky Way. The Artemis cluster contains 135 young massive stars and thousands more less massive stars. The size is just 2 light years. And by observing these massive stars, the scientists defined a limit for maximum mass of a star at 150 solar masses. This is N81, a star formation region in the Small Magellanic Cloud at a distance of 200,000 light years. The size is 12 light years. This region contains 50 stars, the brightest of which have a luminosity of 300,000 times that of the Sun. And the closest pair of the stars are just at a distance of 1/3 light year. This is a nice picture that shows you the satellite galaxies of the Milky Way. The first two discovered satellite galaxies were the Large Magellanic Cloud and the Small Magellanic Cloud. Here, the Large Magellanic Cloud is bigger. In the Small Magellanic Cloud, they are connected by a bridge of gas. The Small Magellanic Cloud has an irregular shape because it experiences the gravity of the Large Magellanic Cloud plus that of the Milky Way. And eventually these satellite galaxies will merge with the Milky Way and will become a part of the Milky Way galaxy. This is IC 2574. It's also called Coddington's Nebula. This is a dwarf spiral galaxy at a distance of 12.8 million light years. It was discovered in 1898 by Edwin Foster Coddington. This galaxy is a member of the Messier 81 group. 90% of the mass is dark matter, and we can see from the bright blue color that this is a starburst region. This is the irregular blue compact dwarf galaxy UGC 11411 at a distance of 50 million light years. It has 1/10 of the size of the Milky Way, and it contains clusters of young hot massive stars. NGC 4424 at a distance of 54 million light years. It has a black hole at the center with a mass of 60,000 to 100,000 solar masses. It has a tidally stretched cluster of stars which was called Niculi at just 1300 light years from the center. And at the bottom, this tiny galaxy, this is LEDA 213994. This is a galaxy Messier 100, also called NGC 4321, the Grand Design Intermediate Spiral Galaxy. Grand Design because it has well-defined spiral arms, and intermediate because it's between barred and unbarred. It is at a distance of 55 million light years and has a size of 107,000 light years, so it's about the size of the Milky Way. And Messier 100 has an active galactic nucleus. This galaxy is a member of the Virgo cluster. In 2006, there was a supernova detected, supernova SN 2006X in this galaxy Messier 100. This is an image from the La Silla Observatory in Chile. Supernova is here, this bright spot at the right. Bigger bright spot, that's the supernova. That's a great large spiral galaxy, NGC 1365. It's located in the Fornax cluster. It's 56 million light years distance. Its size is 200,000 light years. This galaxy is a large bar which contains a smaller bar. A big bar, there's a smaller bar, and in the center there's a supermassive black hole with a mass of 2 million solar masses. This is another supernova which was detected in the Great Barred Spiral Galaxy. The supernova was of the type 1A. It was detected in 2012. The supernova is here above the center, this spot. And you can see from October to November, this is the supernova. And January, 2 months later, already a dimmer. Supernova type 1A is an exploding white dwarf with a companion. The white dwarf takes material away from the companion, which could be another white dwarf or a star, until it becomes unstable and then explodes. These supernovas are very important. They can be used for measurements of distances of galaxies, and they are very important for life because they provide the heavier elements that were formed in massive stars. The supernova explosion distributes them into space, and they can be used for future generations of stars, planets, and moons. This is the Barred Spiral Galaxy NGC 2336 at a distance of 100 million light years. Its size is 200,000 light years. It was discovered in 1876 by William Temple. It contains young stars in the spiral arms. Here. And the central region is more reddish because it contains older red stars. This is NGC 520 at a distance of 105 million light years. This is a picture from the Gemini Observatory. This galaxy was discovered in 1784 by William Herschel. It is a product of a collision of spiral galaxies. They are at an early stage of the merger process. This is a Hubble image from the same galaxy, and you can see the main galaxy is at the right, and the smaller one is at the left. This interaction began 300 million years ago, and it has caused a starburst activity. This is a very beautiful image of the merging spiral galaxy pair Arp-271. At the left, that's the spiral galaxy NGC 5427, and at the right, 5426. They are at a distance of 130 million light years. Their combined size is 130,000 light years. This is how the future of the Milky Way and Andromeda could look like in 4 billion years when the merger process starts. This Arp-Madore 2026424. Arp-Madore is a catalog of southern peculiar galaxies and associations that was made by astronomers Horton Arp and Barry Madore. This galaxy pair is at a distance of 704 million light years. We can see a head-on collision. And again, this phase structure comes from the star formation, which was triggered by the merger of the two galaxies. This is the Smiling Galaxy Cluster SDSS J1038 plus 4849 at a distance of 4.5 billion light years. This is the product of gravitational lensing, and the alignment of the background galaxy and the foreground cluster has produced this what called Einstein-Ring. And gravitational lensing was predicted by Albert Einstein's theory of general relativity, and we can see in the universe many examples that prove this theory. This is the Hyperion Proto-Supercluster at a distance of 11 billion light years. Its size is 196 million light years by 196 million light years by 489 million light years. Its total mass is 5,000 times the mass of the Milky Way galaxy. This is a picture from the VLT image, a very large telescope. And we can see this proto-supercluster at the age of just 20% of the universe. This proto-supercluster contains dark matter. The dark matter keeps this structure together. This is a picture from Hubble of a young star-forming galaxies in the constellation of Pegasus at a distance of 11 billion light years. And we can see many tiny galaxies that will eventually merge and merge into bigger galaxies. This is a nice picture of a test of the Artemis pressurized rover, its hardware. And what's special about the rover is this pressurized cabin. So the astronauts don't have to wear their suits while they're in the cabin. And that's a great picture, I think. That was today's video about the Hubble Space Telescope images featuring Arp-271. Thank you for watching. Have a nice day. Bye-bye.